So in this video, we are going to look at elasticity of demand. Before we look at what it has in the packet, I just want to show you how it's developed using a website that I found that explains it pretty well. So just as a reminder, we know that demand functions are decreasing. So when the price increases, the quantity demanded goes down, okay, which is why a demand function decreases. But what about revenue? And revenue is price times the quantity, or that demand function. When the price increases, will revenue go down because the demand drops so much, or will revenue increase because demand didn't drop very much? And we use this concept of elasticity of demand to figure that out. So it just gives an example of, suppose a company's demand is this function, 100 minus p squared, and the company's current price is $5. What happens if they raise their price 5 cents? We're interested in how the price changes compares to the demand changes. So we're going to convert everything to a relative percent. And just as a reminder, like a relative percent is what we do to find it is we do like the new price minus the original divided by the original, or we, in this case, like didn't really calculate the new and the original. We could, but the new price minus the original really is just the change in price. Over, again, like the initial price. So we write it like this as delta P, that's the change in price, over the original price, which we define as P. And so it'd be 0.05 over 5, which is 0.01, which is as a percentage 1%. And then the demand decreased from D of 5, which was 75, to D of 0.05, which is 74.49. That's a total change of negative 0.05025. And again, if we write the relative change, we write the change in demand over the original demand, and they often use Q to represent the demand function as well. So that would be negative 0.05 over 75, which is negative 0.0067. And again, if I change it to a percent by multiplying by 100, I get negative 0.67. So what we're finding is that when we raise the price by 1%, the demand only fell by 60.67%. And therefore, increasing the price more doesn't really make the demand fall drastically. It only fell a little bit. So as a result, we would expect the revenue to still increase. And this is called that it's inelastic. So the elasticity of demand is the measure of how demand reacts to price changes, and it's normalized. And that means the particular prices and quantities don't matter, and everything is treated as a percent change. So if we take kind of logic on the example before, we found like the change in demand over the demand, and then the change of price over the price. And if we kind of put that in terms of derivatives, we would do dq over q and dp over p. And if we simplify that, we get p over q and then dq over dp, which is the derivative of the demand function with respect to the price. And so that is our formula for the elasticity of demand. So it's written in two ways. If you read the textbook, it's written like this. In the packet, and the formula you'll be given is written like this. So given a demand function Q, and we often say Q is equal to D of P, we define it in terms of that, where P is our price. The elasticity of demand is they have the absolute value of P over Q times d prime of p. Again, we always want it to be like a positive number because they're easier to work with. Now, since the demand is always a decreasing function of p, the derivative is negative. That's why we have absolute values, so e will always be positive. But the formula is also written like, since p is already a negative, we can just put a negative sign because a negative over negative equals positive, and then it's the derivative. It's p times the derivative of p divided by d of p, because d of p is the same thing as q. And that's how we'll write it in this class. And we have 3 rules. So if E is less than 1, we say the demand is inelastic, which means if we raise prices, it increases revenue. So the change in demand is not that much. So as a result, the revenue would still increase. If E is greater than 1, then we say it's elastic. In this case, raising prices will decrease revenue. So the change in demand is pretty significant. Changing that price like decreases demand significantly, which would decrease your revenue. And if E is equal 1, we say it's unitary. E equals 1 is at critical points of the revenue function. Okay, and how we interpret it is we say if the price increases by 1%, the demand will decrease by E%. Okay, so we're always looking at the price increasing by 1%, and then this formula gives us the percent change in the elasticity. And again, it's always decreasing because it's technically a negative number, but we just make it positive because economists prefer to deal with positive numbers. So looking at examples, so here's our function. You will be given that on the exam. E of P is the elasticity of demand, F of P is the demand function, and P is the price. So we usually differ in the problems. It will be defined as F of P for the demand function instead of D of P, but you can also define it as D of P. And the elasticity of demand, again, is the measure of how demand reacts to price changes. For the formula, it's normalized, which means the particular prices and quantities don't matter and everything is treated as a percent change. And these are the same rules that we just talked about. E is less than 1, it's inelastic. If it's greater than 1, it's elastic. If it's 1, it's unitary. This is at the critical point, so it gives us the maximum revenue. And the percentage change in demand is equal to the percentage change in price, which is why it's the maximum. So just kind of some real life examples. Luxury goods and the price of certain foods and beverages are generally elastic. So for example, the change in price of a luxury car can cause a change in the quantity demanded. Tobacco and prescription drugs are an example of inelastic goods. For example, the change in cost of prescription drug usually doesn't change the demand because people still need the prescription go. Okay, same with tobacco. Even when they increase tobacco prices, even significantly, generally people are addicted to tobacco, so they're still willing to pay the price. So the demand does not change and is considered inelastic. And that would be kind of shown by the type of demand function that there is. So we're going to look at examples. So the first objective is just finding E of P. So that's what we're going to find first. So let's write that formula. So we have our F of P. We need to find F prime of P. So F prime of P is 12,000 derivative 0, negative 10p squared is negative 20p. And then we're pretty much just plugging that in with our F of P. So we have negative p times negative 20p all over 12,000 minus 10p squared. And we can only really simplify the numerator. So we get a positive 20p squared over 12,000 minus 10p squared. And then you cannot simplify this. Please do not cancel out the p squared. You cannot do that because there's 2 terms in the denominator. Okay, so that's an example of finding the elasticity function.